Hey everybody, in this videos we're going to take a look at a stock price prediction toolkit using large language models. This is quite a project that comes with 8 files and each one iteratively more complex than the previous one. This is going to be two-part videos. I'm going to cover the first 4 files in this video. Let me quickly explain how this works. Essentially, we're going to take in some previous daily prices and only the closing price of like day 1, day 2, day 3, for example. And I make a prediction based on the next day, the fourth day's prediction, right? Something like that. So it's very simple. You can, this actually is going to show also how to do predictions from 2, 3, 4, 5, 6 days or whatever, like, however many prior days. We're actually going to simulate it. And in the more complex implementations, we are actually going to get simulation results, such as final performance report. Here, for example, we have run 25 simulations of 500 predictions per given range. Ranges are, for example, 3-day historical data that has been given, and it keeps track of overall score, direction, accuracy, mean, absolute error, and stuff like that. Here, in this case, we made 500 predictions for 3-day historical data, 5-day historical data, 60-day, 30 days. And this file is written in from best or most performant results to the least performant. In this case, for example, 3-day historical data actually did better than, for example, 60-day historical data. And the second part, which will be a separate video, we are actually doing it with investments, and we actually get trading simulation results, such as this. Here we use GPT-4o Mini to do 200 predictions per the date range for across 150 simulations. And if we look at the first range, like 6 a day, across 116 trades, it was able to make $98 profit. These are simulated profits, of course. And for the 3-day range, it had 8% ROI with $79 profit. And for yeah, yeah, that's right. Okay. And also win rate was 56%. So there's some promising stuff here. But before we continue, I do want to say this is not financial advice. AI can make mistakes, and you should always consult with a professional before investing. Of course, that let that out of the way. Let's take a look at the first four uh, files here, which we will cover in this video, and I will make a separate video for the other two. Now, the files will be available in my Patreon. You can download it. All the files. We're only going to be talking about the first 4 files, but all the files are available at my Patreon. Full files are available at architect level. You'll be able to find the links in the description and in the comments. So we'll start with the get price range.py, which essentially just takes in a stock ticker, and you give it a start date and end date, and it downloads all the information, such as this, the open, high, low, close, and volume for each one of the days for that date range. I particularly, if you pay attention to the date, it is the November of 2023, because we will be using predominantly GPTs, and GPT's last knowledge date was October 2023, because we want to be as objective as possible. That's why I'm starting from November. And I've tested the GPTs with these date range, and they don't have any knowledge of any of the stock prices during that time. So when you run this first file, you just get the CSV with all the data. So we're going to be using the CSV. You can test it with any stock ticker that you like. And the second one, running it, just plots it so that we can actually compare. As a matter of fact, if we have gotten, actually, let me run it so that we can see if we have actually accurately gotten all the data accurately. It's creating a plot, and this is the plot. You can then compare this with your favorite stock website or something. I did, and it was correct. So when doing stuff like this, it's important that you keep track of where you're headed and that the calculations are being performed correctly. So the third file predicted day predicts a single day. Of course, each one of these files have the disclaimer that these are not these are for research purposes, and none of this you should consider to be financial advice. So in this file, we are giving it a data window, so number of days to look back, and then we want to predict by default 1 day ahead. So you can change this data window and run different simulations. This does it on a single day basis. So if we were to run this, it's going to take a look at the last 10 days. Well, it's going to actually ask us for some information. First, I have to say I understand that this is not financial advice. It tells me the available date range, and here I can enter a date such as 2024, 01, 03. Make sure that you don't, it doesn't check for weekends and stuff. So if you get an error, just enter a separate date. And then it asks you number of days to predict ahead. Let's just say 1, because we want to use the 10 days and predict the next day. And it's going to actually get a result from that. We are only using the closing price. So here we have a quick report. Our end date is the 3rd, and we are predicting for 4th. Actual price was 181, and predicted price was 184 with a $3 absolute error and with error percentage. Okay, and we also save the performance report files. I'm not sure which one, but because I have the other files have right stuff here too. Anyway, so yeah, so this is how it works. Now the 4th file actually is interesting because instead of reviewing this myself, actually, I will let my AI code explainer review this 4th file. But essentially here, if you look at the 3rd file, we are getting the stock price range. Actually, directly, in the 3rd file, we are opening the Apple stock prices.csv because that's the one we're using. We load the data, get the user inputs, convert the date time. So this date time can cause some issues. Get the prediction days, enter the number of days to predict ahead. And we get a prediction from OpenAI. You're a stock price prediction analyst. We just pass in the closing prices for each day. And then we create a plot, generate a report, and print the results. Here we load the data, of course, from the CSV, get the index of the start date, and get the historical prices for prediction and round to 2 decimals. Get the actual price for comparison and round to 2 decimals. Get the prediction from GPT, and then do the predicted price. Also, before talking about the 4th file, I do want to say that always make sure to read the terms and conditions of the APIs. Usually for research purposes, this should be fine, but there can be stipulations about actually doing automated trade executions and stuff. So I encourage you to read it. But the 4th file here will actually, if you read, this script performs multiple day stock predictions. So because previous file to predict the day was predicting single day, but in the multiple days, we'll be able to predict multiple days. And we can set some constants and configurations here. For example, our data range is going to be 30, but you can change it to 10 or 3 or whatever. And you enter the days ahead, and then you say how many predictions you want to make. Now, how this works is that imagine we have this line of our entire database, right? When we do that, because we said 30 days, this automatically detects, okay, I'm going to use this 30 days and this 30 days and predict here and this 30 days. So it automatically randomly chunks up this, so you don't have to do anything. It randomly samples out of the entire data set, 30 days. We also use semaphore to limit the concurrent requests to 100 because this can really trigger your rate limits. Also, it can get expensive with just GPT-4. That's why actually we are here using GPT-4o mini. Let me just change that. Just make sure if you use GPT-4o, do that your number of predictions are reasonable because it can get expensive. While building this whole system took me 20 hours, including the second part of the files. And it cost me about $50 during testing and all that. Anyway, so this will actually run you quite a lot of predictions. Let me actually delete all these files so we can see what is going on. So when I run this, we'll be able to see we are getting GPT-4o mini predictions. Of course, it asks me a disclaimer to accept this is for research purposes, and then it makes these predictions. And it also calculates the direction accuracy, the differences, and then we get the prediction report. We made a total of 30 predictions. Mean error was 0.27%. Mean absolute error is here. Accuracy metric says that it was 56.7%. 17 out of 30 times it corrected the direction correctly. And the predictions were 63% of the time within 1% and 96.7% of the time within 3%. And here we have the detailed results as well. Okay. And we also have a chart. The green ones show the correct direction predictions and the actual and the differences from the actual. Okay. So don't look at this. This is not, this is not sequential. So don't think that, well, it went down. Why does it say red? Because it went down, because this is not sequential. It's just the random parts from the data set. Okay, so now I'm going to let AI Code Reviewer review this because this is quite long at 300 lines. But before we do that, if you do want to become a patron, I will make a video about the second part, such as the Monte Carlo simulations, because once we predict multiple days, then we want to run those actually multiple times, such as we want to do 30 predictions, like, for example, for different data ranges, like what would this work out with just 3 days of historical data, 10 days or 30 days, right? So this does that. The second, we also introduce performance weights, like direction accuracy gets 40% weight and mean absolute error. So you can actually customize these here as well. The next one, which we won't get into detail, has different date ranges, but it also performs multiple simulations of the same runs. And then the third one actually uses play money to invest $1,000 each time the movement direction considers positive outcome in the prediction. And when we actually did that, we were able to see that most of the time it ends up in positive. So, not always, but if you look at this one, it made $75 profit across 69 trades, for example. This one as well. So this one as well. So I don't know if this is a fluke, because it seems hardly likely that you can just predict the next day just by looking at prior dates. But here it is anyway. So this is a simulation. And if you do decide to become a patron, you can download the second part of the files as an architect member. But for at the $30 level, you can download the first part. Anyway, I hope you enjoyed this, and I hope I was able to explain how this works clearly. I want to explore this more, so expect maybe more videos on this, and do let me know what you think. And now we'll just move on to the code review for the predict multiple days. Before I do that, I would like to mention that if you're enjoying my videos, you can find many more at my website, ecohive.live, and watch all the videos for free. I work on this every day, so I try to come up with interesting and useful projects. And if you're a patron, you can download the source codes for each, of course, and check out my 1000x Cursor course if you're serious about building interesting projects in Cursor, which in my opinion is still the best AI code editor. So without further ado, we'll move on to the code review. Thank you for watching, and see you in the next video, probably part 2 of this.
This first segment sets up our environment by importing all necessary libraries and modules required for data manipulation: Pandas, NumPy, visualization, Matplotlib, asynchronous operations, asyncio, and AI integration, OpenEye. These imports package everything neatly like a well-organized closet, ready for our coding endeavors. Following this, we define a display warning function, which serves to alert users with a friendly yet firm reminder about the nature of this tool. It's only for research and not intended as financial advice. Before the tool springs into action, it ensures users are aware of this disclaimer, almost like asking them if they're sure they want to proceed into this adventure of data prediction. Additionally, this snippet includes the constants and configuration settings, like data range, number of predictions, and reading environment variables for API keys, setting the stage for our stock prediction extravaganza. Consider these your backstage pass to all the critical parameters and settings you'll need throughout the rest of the script. This segment introduces the getPrediction function, which is an asynchronous function designed to fetch stock price predictions from GPT-4. Using an async technique with semaphore, it manages the number of simultaneous API requests to ensure that things don't get too congested, somewhat like having an efficient traffic light system. The function prepares a prompt with historical price data and sends it off to GPT-4 to get a prediction for the subsequent day's stock price. It employs error handling to catch any mishaps during the prediction process, printing a colored error message if things go awry, as if it had built-in comic relief to blow the tension away. The Make Predictions asynchronous function takes the stage here, orchestrating the entire prediction operation in parallel. This part of the code kicks off by reading stock data from a CSV file, like flipping open a big, dusty financial book, and proceeds to prepare for simultaneous AI predictions using the magic of semaphores within Python's Asyncio library. With an adept mix of randomly chosen data points and historical price slices, Make Predictions sends multiple prediction requests simultaneously to our GPT-4 model, coordinating the entire effort with the precision of an air traffic controller. It captures each prediction's result, including predicted prices and accuracy metrics, all while keeping the console lively with colorful prediction summaries. This function is a hub of activity, collecting the guts of our prediction data, ready for further analysis. The plot results function creates a visualization that showcases both prediction accuracy and directional correctness. Think of it as making our data points visually dance to the tune of stock market predictions. Equipped with points, lines, and a color code, lime for accurate predictions, red for less accurate, it paints a vivid picture of how our predictions stack up against actual values over time. By presenting both predicted and actual stock prices side by side, it helps analysts quickly spot trends, identify areas where predictions hit the mark, or went astray like a wayward golf ball. This visualization is a sense of complex data in a digestible format, one that pleases both the eye and the analytical mind. The generate report function is akin to the diligent accountant of our script. It tallies up all the numbers, calculates statistical measures, and collates all relevant data into a comprehensive text report. This report includes essential metrics like mean error, ME, mean absolute error, MAE, and root mean square error, RMSE, which tell us how far predictions deviate from actual stock prices and by how much. Direction accuracy is also tracked, shedding light on whether the prediction trended up or down compared to reality. It's like the function gives you a friendly nudge with the facts, clearly indicating where the predictive model performed well or stumbled. Finally, the report is safely written to a text you can look back and review your predictive prowess or indulge in some self-improvement if needed. Here we have the main function, the grand finale or conductor that sets the whole script in motion. It begins by printing out a welcome banner, almost rolling out the red carpet for the listeners, namely, the users craving stock insights. The main function makes use of asynchronous capabilities to kick off the prediction process, gathering results from Make Predictions before calling plot results to visualize them in all their anticipated glory. Afterward, the generate report function is brought into action to summarize all the work into a cohesive report. The harmony between functions here is akin to a well-orchestrated symphony. Finally, the script is equipped with a launcher. You guessed it, the tried and true if name, quiquis main, block, kicking off the event and ushering all those functions into motion when the script is executed directly.
I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.
Now, listen to me. I've been trying to code, and I like coding. The fact that I can code and make things happen, but how do I do it? Fast with AI. I heard about it. It's easy. So I came across 1000x Cursor course. Yeah, that's great. It just made everything super silky smooth. It just worked. I'm telling you.
1000x your coding